Hi, this is the video for assignment number 4 of signal system. Number 1. Find the Fourier transform of the following signal by using FT properties. The FT properties of rect T is SA in brackets of omega over 2. Then we substitute the rect T of 1 over 3 T, which is the properties of Fourier transform. We need to change the output, which is 3 SA in brackets of 3 omega over 2. Then omega W, 3W over 2. Then we add some more, which is rect in brackets of 1 over 3 in brackets T minus 4. Then we change it for the transform properties. 3 times exponent J W4 SA in brackets 3W over 2. Then we add the 2 in front, which is 2 rect in brackets T minus 4 over 3. And the answer is 4 exponent minus J W4 in brackets sine 3W over 2 over W. Number 2, YT is equal to T squared WT. T squared WT, change it to Fourier transform, we get T squared times T squared over dW squared times with the Fourier transform of WT. Then we change the Fourier transform of WT that we just got, which is 4 exponent minus J W4 sin in brackets 3W over 2 and then over W. For number 3, ST is equal to integration of T minus infinity WT dt. Fourier transform of ST is equal to W times dW over dW plus pi omega naught times dW. Then we change the W dW over dW, which is the 4 exponent minus J W4 over dW times sin 3W over 2 over W plus 2 pi dW. For second, x1 f equals to f f try t sinc squared f. Okay, x2 is f rad t equals to sine f sinc f. Okay, determine the inverse Fourier transform of yf equals 2 try f. To try f converted Fourier transform is 2 sinc squared f. I'm sorry, 2 try t. Then 2 sinc squared t converted Fourier transform, we get 2 try minus t. But since try in brackets minus t is equal to try t, so 2 sinc squared t converted Fourier transform is equal to 2 try t. So yt is equal to 2 sinc squared t. For the second one, since ft rect t converted Fourier transform, we get sinc t f Fourier transform of rect t minus 1, we get exponent minus j to by f sinc f. So inverse of exponent minus j to by f sinc f is rect t minus 1. Question number 2. Given the figure mt equals to 1, go to Vt, send the feedback Ct equals cos wct. That is the circuit. Basic modulator circuit is shown in figure. Relation is multiplication between data signal mt. Right. A1. Analyze the Fourier transform of the signal Vt by using modulation properties. Modulation property Vt equals mt times dot ct is equal to 1 dot cos wct. Okay, multiplication in time domain is equal to 1 over 2 time convolution frequency domain. Vw is equal to 1 over 2 mw times cw. Ct is carrier signal, mt is data signal. Fourier transform of Vt is Vw. Therefore, mw equals Fourier transform of mt is equal to Fourier transform 1. mw is equal to 2 pi dw. And cw is equal to Fourier transform cos wct is equal to pi dw plus wc plus dw minus wc. And 1 over 2 times mw times pi dw plus wc plus pi dw plus and minus wc, and we get 1 over 2 mw minus wc plus 1 over 2 mw plus wc. VW is equal to 1 over 2 MW minus WC plus 1 over 2 MW plus WC is equal to 1 over 2 M is 2 pi D 2 pi dW minus WC plus 2 pi dW plus WC. So we get VW is equal to pi dW minus WC plus dW plus WC. Question A2. Sketch the spectrum of signal Vt. This is the spectrum. The pi MW for the data and the CW pi dW plus WC and dW minus WC. Spectrum of modulated signal Vm pi minus WC on the right side pi WC. For B, energy dissipated by resistor using Parseval's theorem. The Parseval theorem. E equals to integration to infinity minus infinity to infinity and xt I squared dt equal to 2 pi integration of minus infinity to infinity this one I forgot what the name is. XW squared. It's not XTI, it's XT this and squared. The negative value turns to positive value. Energy dissipated by resistor E is equal to integration of 0 to t V squared RT over R dz. Then we move the 1 over R to the outside. Again, integration 0 to t VRZ squared dz. In frequency domain, E is equal to 1 over 2 pi R integration of 0 to W0 VRW squared JW. VRW Fourier transform is equal to 2 exponent minus 60 ut is equal to 2 times 1 over 6 plus JW. So E is equal to 1 over 2 pi R. We substitute the VRW. Then we get the answer is E is equal to 1 over 12 pi minus 1 over 2 pi times 6 plus JW0. Last question. Sketch the periodic signal of KT. Okay, given the signal KT is equal to summation of infinity C equals to minus infinity and T plus Ct with T equals to 3 seconds. So we draw the kt, which is the periodic repetition of mt, and we get this Fourier series representation of kt is kt equal to summation infinity k equals to minus infinity ak dot e exponent j k w naught t. Ak is Fourier series coefficient of kt is equal to or an is equal to 1 over t integration of kt dot exponent minus j kw naught t dt. T is 3 seconds, so the value of kt is 1. The range is 0 less than or equal to t less than or equal to 1, and kt equals to 0. The range is 1 less than t less than 3. So ak is equal to 1 over 3 integration 0 to 1 1 dot exponent negative j kw naught t, and we solve it. We get 1 over 3 dot exponent minus j kw naught over 2 minus 2j sin kw naught 2 over minus j kw naught. And we get ak equal to 2 over 3 dot exponent minus j kw naught over 2 sin kw naught over 2 over kw naught. W naught is equal to 2 pi over 3. Then we solve with the W naught's value 2 pi over 3. We get ak y equals to 1 over 3 exponent minus j k pi over 3 sin k pi over 3 over k pi over 3. Replace the k with n, which turns into sin pi n over pi n is sin n. So kt is equal to summation of infinity k equals minus infinity ak dot exponent j kw naught t substitute everything. Then we get kt equals to summation exponent summation infinity n equals to minus infinity 1 over 3 exponent minus j n pi over 3 in brackets 1 over 2t sec n over 3. For number 2, this equation 1, but the t is 200 seconds and wt is 2 pi over t, which is pi over 100. So we get ak equals to 1 over 3 exponent minus j k pi over 100 sec k over 100. For magnitude or amplitude spectrum of non-period signal, mt is this ak is equal to 1 over 3 the negative value and sec k over 200. Next, b, given xt equals to exponent at ut, Fourier transform of xt xjw equals to integration of minus infinity to infinity xt dot exponent minus gwt. Then we integrate it. Turns into exponent at ut exponent minus jwt, because xt is equal to e exponent at ut. Then we get xjw equal to exponent a minus jwt over a minus jw. Then we substitute the 0 and infinity. We get x jw equals to minus 1 over a minus jw. We change the negative to positive, equal to 1 over jw minus a. So the magnitude of x jw is equal to 1 over square root of w squared plus a squared. And the phase of x jw is equal to 1 over tan inverse w over minus a. We get tan inverse w over a. That is all. Thank you. Modulus. I remember now.